Geometry students, to the homework up video, page 120, page 521. Let's go ahead and get started with the assignment. First of all, numbers 1, 2, and 3. We're going to match up the equation with the proper graph, okay? So actually, let's just take a look here at letter A, if you would. Notice that the center here is over 1 and up 2. So the center is 1, comma 2. That's a huge help. That means we're looking for an equation that has a negative 1 and a negative 2 in the parentheses. We'll look at this. Negative 1 here with the x and a negative 2 with the y. So this one here, number 2, has to be letter A. So letter A. Alright, now let's take a look at this. Notice here the center of the circle is right about here, it looks like to me. That's negative 1, positive 1. So negative 1, positive 1 is the center. So that means we're looking for a positive 1 and a negative 1. Well, here it is. Positive 1 with the x, negative 1 with the y. So we're looking pretty good. This will be B. So this one here has to be C. Now, by the way, notice here the center is 0, 0. Notice how they did not write x minus 0. Nor did they write y minus 0. Okay? They did not do that. And you can if you want to, but most books won't. They just put x squared plus y squared because x minus 0 is x, and then x squared is x squared, okay? So this one here would be letter C. Alright, let's move on now to number 4. Find the center and radius of this circle, okay? Well, first of all, the center would be, change the sign of this number, positive 2. Change the sign of this number, negative 4. So there's the center. Now, the radius is this number over here, written with a power of 2. So how can we rewrite 25 so that it has a power of 2? Well, remember, 25 equals what? 5 squared. So instead of putting 25, I can put 5 squared. Now that I've rewritten this side with a power of 2, the radius is obviously just 5. Alright, moving on to number 5. Write the equation of a circle that has this center and this radius. Well, I've told you anytime you're asked to write the equation of a circle, you need two things, the center and the radius, and they gave both of those to you. So the equation is very simple. X, change the sign of the 1, negative 1, quantity squared, always a plus sign here. And then y, change the sign of 3, so negative 3, quantity squared, equals, and then the radius would be squared. Now you're welcome to put 4 squared, or you're welcome to put 16. It really doesn't matter to me, okay? Alright, let's continue on and take a look at number 6. Okay, first of all, we're going to find the coordinates of P. Now when you're asked to find the coordinates of P, students, that means you're looking where the blue line and the green line intersect. So the only way to accurately do that is to take the two equations. Here's the blue line equation. And here's the green line equation. The only way to find where they intersect accurately is to use substitution or linear combination. Now substitution looks to be the easiest. Y equals this. So if that equals y, pick it up and put it in for y, okay? So in place of y right here, I'm going to put 3x plus 13. And now I have an equation right here that has all x's. I'm going to take this negative 2x, bring it over and make it a positive 2x. I'm going to take this positive 13, bring it over and make it a negative 13. Okay? So now I have 5x. 3 plus 2 is 5. Negative 2, negative 13, negative 15. Divide both sides by 5. X equals negative 3. Now if x equals negative 3, come up here to your x right here and put what in for x? Negative 3. Well, 3 times negative 3 is negative 9. Negative 9 plus 13 is 4. So y equals 4. So now you have the intersection point of negative 3, comma 4. Alright, let's continue on. Find the radius of P. Well, the radius of P is going to be, well, we already know this ordered pair. Let me change the color so we can see it a little better. We already know this ordered pair right here is the circle, because I'm really going to need that to find the length of the radius. Now students, as I studied this and tried to find the radius of P, I'm trying to find the distance from here to the outside of the circle, and to be honest with you, I'm thinking they might want us to do just a little assuming here, because, and I would love to hear back from some of you students on this, but as I look at this right here, I need to find a point on the circle, okay? And I'm not really seeing that as an option. I see this point F right here, but I don't know the exact ordered pair of that F, okay? Now it looks like to me we're below this line right here. See this line right here? This gray line? We're barely below it. So here, each one of these tick marks is 5. Do you see that? Here's the origin, 0, 0 right here. -5, -10, -15. So every tick mark is 5 units. So I'm assuming from here to here is 5, and then from here to here is 5 more. For a total of 10. Now I'm probably missing something somewhere. If I was there in class, y'all could point it out to me, but I know the answer is 10, and it's more like an estimation to me than being accurate. I mean, being totally accurate. But I will continue to look at that, and I'll let you guys know if I come up with something different. But the radius would be 10. Now we're going to write the equation of P. So we're going to write the equation of circle P. Okay. So anytime you're writing the equation of circle P, you need two things. Remember, you need the center, and we have that, and you need the radius, and we have that. The center is -3, 4, and the radius is 10. So the equation would be change the sign of your -3. So x plus 3, then quantity squared, then a plus sign, and then y, change the sign of the 4. So -4 quantity squared equals 100, or 10 squared, whatever you would like to put there, okay? And I will continue to study this radius thing and get back with you guys if I find anything different on that right there. Okay, moving on to numbers 9, 10, 11. We're going to match up the circles with the equations once again. Well, this one here has a center of 0, 0. So right away we know A is going to be number 9, because x squared plus y squared, that's the only equation that basically has a 0 here and a 0 here. So we know letter A is for number 9. Now, if you'll look here at letter B, the center of the circle is right here. Now that's over 1 and down 2. So the center is 1, -2. So we're looking for an equation that has a -1 and a +2, and here it is right here. So letter B would definitely go along with number 11. So obviously number 10 is C. Let's go ahead and take a look at number C. Here's the center right here, which would be -3, 0. Okay, so if that's the center, then -3 would be a +3, and of course for a 0 right here, we just have y squared. So there we go. Alright, moving on to numbers 12, 12, 13, and did I cover some of these up here? Let's see if I did. I did not. Alright, why did I not have numbers 13 and 14? Well, that's okay. We'll do 12, 13, and 14 and 15 anyways. And so here we go. Number 12, the directions say to determine the center of the circle and its radius. So for number 12, the center would be -2, +3. -2, +3, and the radius would be 6, because we're going to rewrite this as 6 squared. 36 is the same thing as 6 squared, and so the radius would be 6. Alright, let's take a look at number 13. It's not on the screen up here in front of you, but it is in your book, okay? So the center for number 13 would be +1/2. Change the sign of the -1/2, +3/4, okay? So +1/2, and that should be a -3/4. Now for the radius, we have the right side is 1/4, okay? How can I write that as a power of 2? Well, think about it, guys. 1/2. If I take 1/2 times 1/2, I get 1/4. So in place of the 1/4, I can put this right here. And now I've rewritten 1/4 negative 5, negative 2. And then the radius, we're going to rewrite the 1 with a power of 2. Well, 1 equals 1 squared. So really you can just put a 2 right here because 1 times 1 is 1. So the radius would be 1. And then on to number 15. It's not here on the screen, but it's in your book in front of you there. Number 15, the center would be 6, negative 6. 6, negative 6. And then of course you can rewrite 4 as 2 squared. So the center or the radius would be 2. Moving on to numbers 16 through 19. Write an equation of the circle. Okay, for number 16, the equation would be x plus 4 quantity squared y minus, put a plus sign here, y minus 0 quantity squared equals the radius squared. Now of course for y minus 0 squared, you're more than welcome to just put y squared. You can also put 4 if you want to. Pretty simple. Alright, number 17. Here's number 17 right here, okay? Well, we would say x minus 6, change the sign of the 6, plus, and then y plus 1, change the sign of the 1, quantity squared equals, and then square root of 3 squared, which of course would really just be 3 if you want to put a 3, alright? Number 18. Number 18 is right here. Change the sign of the negative 5. Change the sign of the negative 3. And then the radius is 3 halves, so we put 3 halves squared. So 3 times 3 is 9, 2 times 2 is 4. You're also welcome to put 9/4 if you want to. Alright? And then lastly, number 19. Change the sign of your 7/4, so x plus 7/4 quantity squared plus y minus 3 halves quantity squared equals, and then you square the radius, so 4/3 squared. Square the 4, that's 16. Square the 9, or square the 3, that's 9. So really you could put 16 over 9 if you would like to, or you could leave it 4/3 squared. That's fine also. Pretty simple so far, guys, not difficult. Alright, numbers 20 through 22, they want us to sketch the graph, so this shouldn't be too difficult. First of all, the center would be 0, 0, and the radius would be what? Well, 25 can be rewritten as what? 5 squared, so the radius is 5. So here we go. It's very simple to do, guys. Go ahead and draw your coordinate plane. You always plot your center first. So plot your center, 0, 0, and then from there, I always draw 4 radii. So the radius is 4 or 5. So go over 5, go up 5, go over 5, go down 5, and there's your circle. I am no way, shape, or form going to take off points if your circle's not perfect. We're just trying to get a basic sketch of the graph, okay? There it is. Alright, number 21. The center would be what? 0, comma, positive 4. Change the sign of that 4. The radius, well, 1 is the same thing as 1 squared. So your radius is 1. So here we go. This will be a pretty small circle. So our center is at 0, 4, which is right here. And your radius is 1, so go over 1, go up 1, go over 1, and go down 1. And there's your circle, pretty small circle, but there it is. Okay? Alright, moving on to 22. Okay, your center would be negative 3, comma 0. So negative 3, comma 0. And your radius would be 3, because you can rewrite the 9 as 3 squared. So, draw our coordinate plane here, making this left side a little longer over here for a reason. this and sketch the graph, okay? Actually pretty simple. Okay, for numbers 23 through 26, they want us to use these points here to find the equation of the circle containing those 3 points. So they've kind of walked us through the steps here to help us, okay? First of all, let's go ahead and plot these points. They could be a big help to us. So we have 6, negative 1, and it might help to get a really big picture. I'm going to open up another page over here. Let me go back and see. Yeah, okay, let's go ahead and get another page here. I'm going to draw a pretty big coordinate plane so we can get it really good. So we have a lot of space because we're going to do a lot of writing on here, a lot of lines, equations, stuff like that. So let's get a lot of space here so it's not all crammed in there and hard to see things. Now, -6, -1. So -6, 1, 2, 3. Where's 6, -1? So there's 1 point. -4, 3. So -4, +3 right here. And then 2, -5. 1, 2, 3, 4, 2, -5 right there. So there's our triangle for the most part. I'm going to go ahead and sketch a triangle. I know they want us to find the equation of a circle, but the first thing you have to do is draw a triangle, okay? And then here's what you do next. Now listen to me carefully, students. What we have to do is find the perpendicular bisector of 2 sides, and where we have to find the equations of the lines that are perpendicular bisectors of 2 sides, okay? Let me go ahead and write the ordered pairs up here while I'm talking here. -6, was it -6, -1? Yeah, okay, good. -6, -1. And then we're gonna find where those 2 perpendicular bisectors intersect, and that will be the center of the circle, okay? And then we'll find the radius from there. Okay, here we go. Let's see here. What do we have? We have -4, 3. And we have 2, -5. Alright, here we go. Now, find 2 equations for 2 of the perpendicular bisectors, so it really doesn't matter which 2. I guess we'll use this one here. So let's find the midpoint. The midpoint for these 2. Now remember, here's how you find the midpoint. X plus x divided by 2, comma, y plus y divided by 2. Now you can do that in your head, guys, okay? Add the 2 x's together, divide by 2. You'll get a -5. Add the 2 x's together, divide by 2, and you get a 1. So there's the perpendicular bisector, which looks right. -5, 1. So I took this point here, used this formula, and got the midpoint. Now when you do that one more time, so we'll take the blue ink, and I guess the midpoint looks to be about right there. So we're going to take this point and find the midpoint of those 2 points. So here we go. Add your x's together. -4 divided by 2 is -2. Then we're going to add our x's together. -1, or your y's together, excuse me. -1, -5, -6 divided by 2 is -3. And again, we lined it up pretty well. That point is just about lined up with -2, and it's just about lined up with -3. So we're actually doing pretty well. Okay. So there's my 2 midpoints. Now, don't lose sight of the trees for the forest here. It's saying to find equations for the 2 perpendicular bisectors. So far, students, what we've done is we found the midpoint. Now, perpendicular, if you kind of sketch them, there's one of them. That's pretty perpendicular. Looks pretty good. Here's the other one going this way. That's pretty perpendicular. So it looks like they're going to intersect approximately right there. So we're going to keep that in mind, okay? Now, how do I find the equations of these 2 lines? Well, to be honest with you, I should have used a green line for this one here to stay consistent. So we can really use color that way as we talk about each line. So, now, here's what we're going to do. If I want to find the equation of the green line, I need to know a point and the slope. I have to know a point that lies on the green line. Well, I already know a point. Negative 5, 1 lies on the green line, does it not? Right here. I have to know the slope of the green line. Okay? I don't know that, however. I know this line here and this line here are perpendicular. So if I can find the slope of this line here, then the slope of this line has to be the opposite reciprocal. Okay, so what is the slope of this line here? Well, take this point here and this point here and find the slope of the black line. Okay, of this line right here. How do you find the slope? Well, if you remember, it's y minus y over x minus x. Okay, so with that in mind, here we go. Y minus y, negative 1 minus 3, negative 1 minus 3, negative 4, x minus x. Watch your signs. Negative 6 minus a negative 4. Negative 6 minus a negative 4. That's negative 6 plus 4. That's negative 2. So I have negative 4 over negative 2. Well, a negative 4 over a negative 2 is a positive 2. So the black line slope here is negative 2. Or positive 2, excuse me. It'd be a positive 2. Now, that means the green slope, I'm going to put m equals, the green slope would be, well, I'll do it down here. The green slope would be, you change the sign, negative, the 2 is positive, so you use a negative, and you flip 2 over 1, and you get 1/2. So students, I'm really all set and ready to find the equation of the green line, okay? I can do that pretty quickly here. So I'm going to go like this, and pull this information over here. We're going to use that later. Now, next, let's find let's talk about the blue line now for a second. Okay, for the blue line, I need a point that lies on the blue line, and I have a point, negative 2, negative 3. I just need the slope. Well, remember, if I can find the slope of this line right here, and the slope, that will help me because this line here and this line here are perpendicular. So if they're perpendicular, if I find the slope of this black line right here, then this line here is the opposite reciprocal. So let's very quickly find the slope of this black line here. I can take this point here and this point here and find the slope of the black line. So here we go. Y minus y, negative 1 minus 5. Watch your signs. Negative 1 minus a negative 5. That's a negative 1 plus 5. That's 4. So my numerator is 4. Okay? So far my m equals 4 over. Now, x minus x, negative 6 minus 2. Negative 6 minus 2. That's negative 8. So if you reduce that, the black slope is negative 1/2. So if the black slope right here is negative 1/2, then the blue slope would be a positive 2. Flip the fraction 2, change the sign. So now I'm doing really well. Now I can quickly find the equation of the green line, and I can find the equation of the blue line. Let's do the green line first, okay? So here we go. Y equals mx plus b. So y would be 1, x would be, or m would be negative 1/2, x would be negative 5 plus b. So 1 equals positive 5 over 2 plus b. Bring the 5 over 2 over, make it negative. So 1 minus 5 over 2 equals b, or 1 minus 2.5. That would be negative 1.5, or negative 3 over 2. You should have a fraction button on your calculator. So if you struggle with fractions, use your fraction button. 1 minus 5/2 is negative 3/2. Okay, so I know what the slope is of the green line. I know what b is of the green line. So my green equation is y equals negative 1/2 x minus 3/2. There we go. Done with the green equation. Okay, pretty cool. Now let's go on to the blue equation very quickly here. Now, I am going to use y equals mx plus b like I always do. So for y, I'm going to put in negative 3. For m, I'm going to put in 2. For x, I'm going to put in negative 2. And then plus b. So now I have negative 3 equals negative 4 plus b. Bring the negative 4 over. Bring the negative 4 over and make it a positive 4. And you're left with 1 equals b. So I know what the slope is. I know what b is. So my blue linear equation would be y equals 2x plus 1. Okay? Now, let's go back to what we've done so far, okay? Let's go back to our picture here. We found the perpendicular bisector. The perpendicular bisector. We learned a long time ago that whenever you find the intersection points, the intersection point of the perpendicular bisectors of a triangle, that is the point that is always equidistant from the three vertices. So what I have found is a point that is going to be the same distance from all those vertices, okay? Now how do I find this intersection point? Well, that's what I'm going to do now, and that's what problem number 24 says to do. Find the intersection of your two perpendicular bisectors. 23 is done. We found the equations of the two perpendicular bisectors. Now we're going to find where they intersect. Well, the only way to do that is to say, okay, this equals y, so pick this up and put it in place of y. So I have 2x plus 1 equals negative 1/2 x minus 3/2. Now, personally for me, I don't like all these fractions. I have a denominator of 2 and a denominator of 2, so very quickly, I don't always do this, but I'm going to do it this time. I'm just going to multiply everything by 2 to get rid of my fractions. Now, you don't have to do that. If you want to not do that step, and you just want to bring the negative 1/2 over, make it positive and all that, that's fine. For me, I don't want these fractions, so I'm going to multiply everything by 2 just real quick. 2 times 2 is 4. 2 times 1 is 2. 2 times 1/2 is negative 1. And 2 times negative 3/2 is negative 3. There, I like that a lot better, okay? That's just me. So I'm going to bring the negative 1x over and make it a positive 1x, so it's gone. I'm going to bring the positive 2 over and make it a negative 2, so it's gone. 4 plus 1 is 5x. Negative 3, negative 2 is negative 5. Divide by 5, x equals negative 1. Now if x equals negative 1, come to this x right here and put a negative 1. 2 times negative 2 is negative 2. Plus 1 is negative 1. So it looks like we're getting negative 1, negative 1. Now that's kind of a stretch. Let me check my work here. I think I might have made a mistake. Because really our points aren't lining up very close to that. Over here, I'm getting more like negative 1, negative 2. So let me quickly pause the video and check my work just to make sure that we're correct. Yes, students, everything is totally accurate. So our point of intersection of the green line and the blue line is negative 1, negative 1, okay? And that's why you can't always go by your graph exactly, okay? So I'm going to put the intersection point in red. So the center of the circle is negative 1, negative 1. Got it? Okay? Now, next they ask us to determine the radius of the circle, okay? Now, if we're going to determine the radius of the circle, all you have to do is find the distance from this point to the vertex, or from this point to this vertex, it doesn't matter which one, or from this point to this vertex, it doesn't matter which one, okay? It really doesn't. I just feel like finding the distance from here to here. So the 2 points I'm going to use are obviously the center of the circle, which is negative 1, negative 1. And this vertex here, which is 2, 5. 2, negative 5. So I'm going to find the distance from here to here, and that'll be my radius. Because really, students, think about it. This circle that we're going to put around this triangle. And I'm not going to do a very good job of it, as you can tell. Pretty bad job, but this is going to be a radius right here. And so will this. And so will this, okay? All of those are radii of the circle. So I'm going to find the distance from here to here. Distance formula, remember. X minus x, negative 1 minus 2. Quantity squared plus y minus y, negative 1 minus 5. Quantity squared. So what I have now is negative 1, negative 2 is negative 3. Square that and you get 9, okay? Plus negative 1, negative 5 is negative 6. square negative 6, and you get 36. 36 plus 9 is the square root of 45. So there is the radius. The radius of the circle is square root of 45, and the center of the circle is negative 1 comma negative 1. Okay, so really not too bad. Now, I did notice, I think I might have made a mistake here somewhere, because I think they're getting 25 for the radius in the book. So just hold on 1 second, and let's make sure we're not making a mistake. Negative 1 minus 2, 3 squared is 9, and then we have a negative 1. Yes, my fault, students, I apologize. We have negative 1 minus a negative 5. Negative 1 minus a negative 5 makes it negative 1 plus 5, which gives you 4. And 4 times 4 is 16. There we go. And 9 plus 16 is 25. So that's much better. So, sorry about that mistake. There's the radius of the circle. Square root of 25, which would then be 5. So there's the radius, okay? Square root of 25, which is 5. So let's go back and look. They want us to write the equation of the circle. So here it is. The equation of the circle is x, change the sign of your negative 1 plus 1, quantity squared plus y, change the sign of the 1 plus 1 squared equals radius squared, where your radius is 5, so 5 squared, which of course is 25. Okay, so there's the center, or there's the equation of your circle. Alright, okay, moving on. Now, students, I'm going to quickly put letters up here, which I didn't do before. X was my negative 6, negative 1, so this is x. This point here is x. You'll see why I'm doing this in a second. Y is negative 4, 3. So this is y right here. So this last point here is z, I believe. Let's see. Yes, z. Okay. Is one side of your triangle XYZ. Now you see why I put the letters up there. Triangle XYZ, a diameter of the circle. Is one side a diameter? Well, students, I want to be respectful of your time and teach you well, but also make things as easy as possible. Look, we know the radius is 5, correct? So if one of these sides of the triangle, whether it be this side, or whether it be this side here, or whether it be this side here, if one of those 3 sides is the diameter, that would mean their length would have to equal what? 10. Does that make sense? If the radius is 5, then the diameter has to equal 10. So what you would do is you would use the distance formula. Now obviously there's no way, just by common sense, that this side here is going to be a diameter of the circle. Okay? There's no way. And so we have to understand that. Now, the only really 2 sides, I could try to sketch the circle again, but it's not going to help. Really, the only 2 sides that could possibly be a diameter, and to me it looks like the more common sense guess would be YZ. That's just my opinion. I don't think this would be. But if you'll take the distance formula and take point Y, which is this, and take point Z, which is this, and use the distance formula, I really believe you'll get out 10. Now I'll do that for you quickly, okay? I was going to skip, but I'll do it for you real quick. You will see the distance of YZ is 10, thus YZ has to be a diameter. So here we go. X minus X, that's negative 4 minus 2, plus Y minus Y, that's 3 minus a negative 5 squared. So we would get 36 plus, let's see, 64. 3 minus negative 5 is 3 plus 5, 8. 8 squared is 64. Add those together and you get 100. And the square root of 100 is 10. So yes, the answer to this question here is yes. YZ, and it's right here for you. I didn't even see that. Here it is. Yes, YZ equals 10. Okay, so there we go. That is how you would do that. Well, guys, I hope this homework